We are practicing graphing with the slope-intercept form. Graphing with the slope-intercept form, where we use y equals mx plus b. So, starting with that, without any further ado, y equals mx plus b. Now, the reason I wrote it like that, I lined up this mx plus b underneath the form of the equation, 1/4 x plus 2. This m is the 1/4 and the b is the 2. So m is the slope, 1/4. b, the slope, the intercept is equal to 2. How does that play out in the graph? Well, the y-intercept is the place where the line crosses the y-axis or is intercepted by the y-axis. So that would be at the point 0, 2. Well, why 0, 2? Because there's no movement in the x, no right or left, so that's 0, but it's up 2. Now, what do we do? Where do we go from here? Well, we rise over run. Slope is literally rise over run. I'm just going to move that over so you can see it. Rise over run. And the rise in this case is 1. We're going to rise 1, and we're going to run 4. So up 4, up 1, sorry, and right 4. Up 1, 1, 2, 3, 4 over. We have ourselves a line. And there it is. Again, rise is 1, up. 4 is positive, so it goes to the right. And then we have our 2 points. 0, 2 is here. If we want, we can graph the other point. It would be the point 1, 2, 3, 4. 1, 2, 3. And there it is, 4, 3. But if we're asked to sketch the graph of a line, we don't really need to write the second point in. It's just interesting to know what it is, because we're taking everything from the y-intercept and then moving from there. Let's look at another example, and in this case, we're going to have a negative slope. So let's see how that plays out. It's going to be a little bit different than what we just saw. And in this case, the equation is y equals negative x minus 3. I'll zoom in on that for a second, just so you see it. Y equals negative x minus 3. And again, we're going to write the y equals mx plus b right beside it or right over it, mx plus b, so that you see the m lines up with the number there, and that's an invisible 1. So m equals negative 1 and b equals negative 3. And now we got a slope of negative 1. So what does that mean? Rise over run. Let's check it out. Rise over run. Negative 1 over 1. Negative 1 over 1. And what does that mean? Negative 1 means down 1 and right 1. Make sense? And here we go. Let's look at it on the graph. Down 1 and to the right 1. I'm going to do it with a different color, otherwise it's going to crash into this other one here. Down 1 and to the right 1 is right here. That's our second point. I'm going to use a ruler this time. Get out. There we go. And we get our line going right on through there, infinitely extending out into space. That's what happens with a negative. Now notice, if we look at the two examples side by side, hey, notice that one line is going down and this one line is going up. If you think of a plane taking off, that would be on the left. Then you're looking at this example where this plane is taking off is a positive slope. Now, think of a plane landing and we have a negative slope. Something to note. So you have a visual image of what these things look like. Let's look now at y equals 3x minus 1. Let's look at that. Zoom in a little bit so you can see the equation. Y equals 3x minus 1. And let's look at y equals mx plus b for this equation. Y equals mx plus b. The m is equal to 3, and the b, y-intercept is equal to negative 1. And what does that mean on the graph? Well, first of all, we have to understand that we've got to look at our y-intercept as negative 1, so we're going to go down here to 0, negative 1, again, 0 for the x value, and the y value is negative 1, so there we go. Now we're moving rise over run. Rise up 3 and run down 1. Or sorry, there's 3 over 1, so run to the right 1. So rise is 3, run 1. We rise up 1, 2, 3, and we run 1. It's up 3 and to the right 1. Get my trusty ruler and my trusty pens with all these different kind of colors, and we can just go extend that over. There it is, another line, and infinitely extending off into space, ladies and gentlemen. Well, let's move on over to our last example, and it looks like y equals, looks like we have a fraction for the slope. Does that worry us? I don't know about you, but I think I'm okay with it. Why? Because it's going to make it easier. The rise over the run is going to be easier when we have a fraction, believe it or not, because it's all separated for us in the fraction. There we go. Let's check it out. So here we go. Y equals mx plus b. M in this case is -2/5. We have a negative in there. B is equal to 5. How does that play out on the graph? Well, B is 5. Well, what does that mean? On the graph, that's at the place 0, 5. So 1, 2, 3, 4, 5 up. And there it is. 0, 5. Now we have a negative slope. That's like a plane landing. It's coming back down. So let's see what that looks like. The rise down to, sounds counterintuitive, but it's -2, right? So rise down 2 and run 5 to the right. It's positive. So on our graph, we go down 2, and then 1, 2, 3, 4, 5 over here, and then we draw a line between those two. Sorry, it's a little crooked, this line. No time for a ruler. Sorry about that. Well, hold on a second. Maybe we'll just make it right. Here we go. There it is with the ruler, a little more straight. And we have our final graph for this exercise. Well, I hope it's been instructional. I hope you understand much better the concept of slope-intercept form and how it applies to graphs. Remember, a negative slope is going to go down like a plane landing, and a positive slope is going to go up like a plane taking off. Happy homework times.